got some examples for the workshop this afternoon. And you can see as the temperature increases, their frequency increases. Sometimes by as much as 5, even 10 kilohertz in an extreme case. As far as I know, humidity would more influence which species can inhabit an area rather than how those species sing, if that makes sense. Like Staphylophoma grossum is very moisture dependent, for example.
Interesting. Awesome. Thank you very much.
Sure.
Okay, we've come to our final speaker of the session, so hang on in there. It's nearly lunchtime. Welcome up, Roel. Thank you.
Hey, everyone. So this is second presentation on our project LEPMON. This morning, Peter was already presenting. There will be a little bit of overlap, but I'm going to try to keep it at a minimum and concentrate mostly on some of the experimental results that we had for this year. So the aims of the LEPMON project, which is funded by the German Ministry of Science and Research, is to have a high quality automated monitoring system for nocturnal insects. And we've seen a couple of those already, but what is unique about our project is that we're really aiming to go to species level, and within Germany, we're aiming at approximately 1,000 species of moths alone, which pretty much covers all of the macro moths in Germany. And then my personal passion is to extend that to as many non-moths as possible. And we're just getting started on that. And our strategy, so this is a collaborative project, and we go the whole pipeline from hardware development, which was mostly done by Dennis, who was also here in the audience. We have data collection and citizen engagement specialists. We have data management, which was done by Peter, who's also here. You saw that this morning. Then we have the AI identification part. And finally, data analysis, which is where I come in. So that also means that I depend on everybody else. So yeah, the device is called the ARNI. Why it's called the ARNI? It's the automatic recorder of nocturnal insects, which, not a coincidence, also works in German. So we can do this in multiple languages. We do time lapses. So every 2 minutes, a picture gets taken. And this is the device. Basically, I'll show you in a sec what is inside this box. This is a security camera casing. We have the widescreen that we can make a photo of. This is a LEPMON. LEPMON was specifically designed by Gunnar Brehm because it has a frequency that is specifically attractive to moths. And the whole thing stands on these layers. And you can either power it by grid electricity or solar panels. So what is inside the box? We have a 20 megapixel industrial camera with a fixed focus of exactly 70 centimeters. And the whole thing is controlled by a Raspberry Pi. And we have a couple of additional sensors inside the box that are recording temperature, pressure, etc. And this is then what it looks like when actually, so we do a flash photography every 2 minutes. This is what it looks like. And on a very good night, this is what you get. And what we see here, first of all, recognizable for anyone working with these kind of things, is the shape of some insect sitting on the camera. From the shape of it, I'm going to say it's probably a leafhopper. This is a particularly good night. And from our camera system, this is kind of the resolution that you get. So extremely detailed pictures of the larger moths. The smaller moths are doing okay, probably something that the AI can deal with. But when you get to these leafhoppers that are about 3 millimeters, that is also for our system just the limit of what we can do. Of course, there are options to increase it. We could decrease the distance to the camera, but then you also have a much smaller screen, so you're going to capture fewer insects. This is a choice we made, and we're going to get pretty far with our goal of 1,000 species. This is a map you've already seen. These are the places where we're deploying the cameras. So we have two aims. One is to catch as many species as possible for a training model. That's where we have our habitat program. And then it goes all the way from the coast. So here we have actually one trap now deployed in the Netherlands. We have bogs, we have mountains, and we go all the way up to the Alps. So we cover pretty much the entire gradient of habitats that you can get within Germany. And then we have our urban gradients, which we have already set up in most of our cities. And this is Leipzig that I work at, and where I will go a little bit in detail. And then we have all these other cities where we have a nice urban gradient, which is our test case. So these are only the pro models. This is big units about this size. Currently under production is the citizen science model, which is much smaller. It's about this size, so comparable to some of the other machines we've seen already. And that is attached to a pole. We have the same light and then a camera and some flashes on it. So this is currently under production, and we don't know yet very well how they perform. And I already see this slide is not exactly as I had intended. So, but anyway, we're going to look at a map. Maps are always good. So this is Leipzig. This is our biggest city. It has about 600,000 people. And we have deployed these traps in 6 locations, of which this is the botanical garden where we do our experiments, and this is our urbanization gradient. And it looks kind of like this. It goes all the way from near natural forests to pretty much complete urban, completely sealed surface. This is well over 80% because even these M2 lots have been built by now. And everything else is somewhere in between. And not very surprising, what you get from that is obviously the highest number of units there, and there's area, almost nothing, but even there's always something, so it's good to monitor. Now, what are the kind of data that we're hoping to get? What we want to present to our stakeholders, which in our current status is mostly citizens who set up these traps in their gardens, but also nature conservation agencies is one. We need to present them species level data because that's what they're interested in, and that need to be reliable. So the species need to be reliable. They also want to know what's the number of every species that we've seen. And from that, we want to calculate reliable estimates of total abundance and or biomass. And from that, we can then extrapolate also diversity estimates. Now, what we were interested in this year, and again, my slide is not exactly as I had intended, is we want to know how often does it happen that a moth gets photographed on the screen multiple times. And for this, we did a mark recapture study. And so we sat down at the trap in the botanical garden, and we collected these moths. We marked at least 50 of them, but not all of them returned to the screen. And basically, it was a simple setup. There's a moth sitting on the screen. We capture it. We paralyze it with CO2. We put some paint on the wing, let it recover, and put it back on the screen. So that's what you see here. And then you have a screen full of very colorful moths. Which kind of look like this, which made it also then possible to track all of these moths through time. And that's what my student helper did. He took, for every moth that we put on the screen, he followed all the subsequent photos in the next 2 weeks, basically, and pointed exactly where this moth was sitting at each time. So from that, we can then calculate how much time every moth spent on the screen on every night. So this is the graph that I will show you first. It looks like a bit much, but every graph here is one single moth on one single night. And what you can see, so the forky structure here is an artifact. Don't look at that, but what you can see is this moth had been sitting there, then it was gone for a couple of minutes, and then it came back and was sitting on the screen again. And what you can see is that most moths actually are on the screen multiple times. So the AI will think that that is a different moth. because it very likely also did not come back at the exact same position. What we can also see here is that there are moths that come back on several different nights to the same trap. So this one even came back almost 2 weeks later to the trap, and in between it was just somewhere else. So this one and also this one also came back on 3 consecutive nights. And then we have our caddis. We marked one caddisfly just because we could. We have lots of caddisfly, and also this one came back on several nights. Now, with this kind of super detailed data, we can actually also look what these insects are doing all night. How long are they staying? When are they there? And how many different locations on the screen are they actually occupying? And you can see that it's also very variable. Some of them are only in one location, they sit there for a while, whereas this one is going crazy and jumped all over the screen the entire night. So if we then wrap this all together and we want to see, okay, so how often does it happen that a moth gets photographed more than once? That's actually the majority. There are more moths that are photographed multiple times than moths that are seen only once. And some of them go up to 14, 15 times. So we will need to do something with that, but this was only one trap with only marked moths. So we figured we can do more. Namely, we can look at moths with very specific gaps in their wings that we can trace over time. So we did that for 2 more locations in our city. And then we get actually a very similar impression. So this is the number of nights that each moth will see. I guess the good news is that the vast majority of moths only come to the screen one night. So in the end, it doesn't look like they're particularly disturbed by the light, but some of them come back on 3 different nights, and we're just seeing one of them coming back on 4 different nights. This was clearly a less productive location, where also there the moths came back on different nights. And if we look at how often, on the far left is the graph I already showed you, how often is each moth seen on the screen in one particular night? That's actually quite similar. Over here it goes up to 15 and up to 12 times. So we got to do something with that information. And unfortunately, this slide got completely messed up. Wait, let me try to, I'm not sure if the people online now got lost completely. Maybe I'm trying to do something about that, which is editing. Maybe you can actually see what I was trying to say. Okay. This is already better. What we're trying to do is do some kind of post hoc correction of the estimate of the number of individuals. If we have enough data for that, we don't know, because there's still a lot of things we don't know how to actually correct. We know it needs to be less, but we don't know exactly how much. And you don't have this taxonomic difference at either the species or the family level. We don't have the seasonal differences because we only did this at the end of the season last year. And maybe most importantly, we don't know how the insects interact. So potentially, if you have a very full screen where insects are moving all the time, their recapture rates will be either higher or lower because of the interactions, and we just do not know that yet. But we're on it. We're going to try collect some more data this year, and then our aim is to provide the best possible counts for calculating these temporal and spatial trends. And with that, I need to thank my student helper, Ryland, for doing all the legwork here, and our funders and you for attention.
Wow. Such a great project. Amazing. It's okay. You're going to kick us off with a question.
First of all, I think that people would landing on the left, not on the okay.
So
I
picky.
wonder if you would agree that moths in your botanical garden have nowhere else to go, so they can come back to the track more often. You've done the same thing in the less forest drilling, lots of other things to do for the moth, that they will be even less likely to come back to the back. That was not in the final list there on habitats.
It is absolutely possible. So the gardens that we looked at, one of them is an urban garden or suburban garden rather, and the other is an allotment garden. Those are places where I would expect that the moths can do whatever they want, and they seem to be flying away and then maybe come back later. So yeah, it's possible. At the same time, our forest site that I showed you these extremely densely packed pictures of are also the places where you're going to expect most of these interactions to take place. And the interactions I can expect either because of the interaction, they will fly away more, but whether then they just go away or whether they come back at a later stage, I don't know. I could imagine both or either. And the only way we're going to find out is by actually testing it.
Lars?
Yeah, but very interesting talk, and it aligns very well with what we've seen from both the interacts and also working with sheaves and working wolves and the large domestic gaps. It seems like people argue that there are just the same ones going back and being seen over time. But if you sit there and catch them, you see that what you thought might be 5 of the universe are 55 instead. And this sort of emphasizes that there are many more around. And just a comment that yeah, like you said, you're looking in autumn, and it should be migrants passing through, and that could segregate the sort of low recapture rates, but that's also something that mostly referring to statements. I still believe that your data is those and stuff. But my question is, do you think we are close to getting bonus estimates now? And how do we translate this?
That I don't know yet. So we're gonna make some kind of statistical model so the numbers need to go down, and they need to go down to somewhere between our whatever the AI estimates is the number of observations of each species of that particular night, and the number of that species that we see simultaneously on the screen. And I can't really judge yet where that's going to lie. What worries me a little bit about the statistical distribution of this is that it's extremely skewed. So it's not going to be some kind of very clean mean number that we can take. So it might become a little bit complex, but I mean, we work with LLM, so doing a little bit of stats on the side is going to be relatively easy, but I don't know where it's going to be.
Jamie?
Thanks. It's really amazing to see this done. I think you showed it really well. If you only see one individual, one species across the course of the night, we can really say nothing about how many times it goes where it comes back. We still can't be sure that it's not the same individual. But one thing I do think we have in our data without doing this whole kind of arduous process of market recapture for each species, we have species-specific kind of estimate of return on data, whatever it would be. So sometimes we do have 2 individuals from the same species on the screen at the same time. And then we really know we have at least 2.
Yeah, exactly.
I think that's it. In here, these 2 images are really valuable. And maybe the ratio of the images that have only 1 compared to 2 or more, maybe there is a kind of addition to our statistical model that can get us a kind of abundance estimate.
Mm-hmm.
Yeah, like I said, it needs to be some that information of at least 2 that's super valuable. So it's going to have to be something more than 2 and something less than 15. How and exactly where we're going to end, I am not exactly sure, but yeah, I mean, the least we can do is just say it's at least 2.
That's less than 15 on the side of your target that the camera is doing, not necessarily on the backside or leaves around. So it's still an interesting although.
Of course, but we know that's with every method. That's nothing unique to either AI-driven methods or automated or light traps, pitfall traps, all that. We're all only making an estimation of what is actually out there. But we do want that estimation to be as accurate and representative as possible. So this is why we're doing this, trying to get closer to that true number. instead of just saying. I mean, the other choice is either it was present on that night, which throws away a lot of information, or we say we have this number of detections, which is for sure an overestimation of the truth.
Yeah, one more, Aoife?
Do you think it was going to test, or if you turn it off one night and you leave it longer, or it's recapture and then work itself?
We're not really planning that. We could do that in our botanical garden trap, but then we would also manually need to go there and turn it off all the time because it's programmed to just go on and stay on. And that's also one of the reasons why we wanted to know, like, how invasive is this to the moths? How often do they come back? Because our monitoring program is really, so we started for this year already, and the trap is basically all of them are going to be running from now until somewhere in October. So that's a lot.
Brilliant, thanks, Roel. And thank you to all our speakers. It is lunchtime. Let's give them another round of applause. And thank you very much for attending the session. Well, do you want me to stop the recording and things?